Let's fill up a crossword based on some carbon compounds. This substance is used by some countries as an additive in petrol since it is a cleaner fuel. This is a substance widely used in alcoholic beverages. In cold countries, especially during the winter, this substance often freezes into ice-like crystals. A German chemist, Hermann Kolbe, for the first time in the year 1847, synthesized this compound from inorganic materials.
Didn't you think that these were interesting facts about ethanol and ethanoic acid?
In this lesson, you will gain a deeper insight into the characteristics and uses of two carbon compounds, ethanol and ethanoic acid. At the end of this lesson, you will be able to analyze the IUPAC name for ethyl alcohol, identify the process for commercial preparation of ethanol, explain the physical properties of ethanol, explain the chemical properties of ethanol, list the uses of ethanol, identify the effects of alcohol on human beings, explain how industrial alcohol is made unfit for drinking, analyze the IUPAC name for acetic acid, state how ethanoic acid is prepared in the laboratory, explain the physical and chemical properties of ethanoic acid, and list the uses of ethanoic acid. The use of ethyl alcohol is widespread in our daily lives. Ethanol is commonly called alcohol and is the active ingredient of all alcoholic drinks. Ethyl alcohol or ethanol is a member of the alcohol family. The molecular formula of ethyl alcohol is C2H5OH. To begin with, let's analyze the formula to derive the IUPAC name for ethyl alcohol. Ethyl alcohol has two carbon atoms. Therefore, the root word for the name of the compound is eth. Further, as it is a saturated compound, it is given the suffix ane. However, due to the presence of the functional group OH, a secondary suffix -ol is added to the name instead of e. Therefore, the IUPAC name of ethyl alcohol is written as ethanol. Ethyl alcohol is also known as grain alcohol because it is obtained from starchy grains. It is additionally known as the spirit of wine because it is a constituent of wines. Ethanol can be manufactured through fermentation of molasses. The process involves slow decomposition of a complex organic compound like molasses into simpler compounds including ethanol by means of microorganisms like yeast. It is interesting to note that except for use of fire, the fermentation of sugar into ethanol is the earliest organic reaction known to mankind. As a typical member of the alcohol family, ethanol is a colorless and inflammable sweet-smelling liquid. It is miscible with water in all proportions. It burns with a blue flame. It is a good solvent that dissolves most known substances. Ethanol can cause drunkenness on consumption, even in small quantities of dilute ethanol. If consumed in its pure form, even in small quantities, it can be poisonous and can prove fatal. pure ethyl alcohol is called absolute alcohol. Now, let's analyze some of the chemical properties of ethanol. We all know that acids on reaction with metals liberate hydrogen gas. Similarly, ethanol readily reacts with sodium to form sodium ethoxide and hydrogen gas. When ethanol is heated to a temperature of 443 degrees Kelvin with excess concentrated sulfuric acid acts as a strong dehydrating agent and removes a water molecule from ethanol. This converts ethanol to ethene. The physical and chemical properties of ethanol make it useful in the pharmaceutical, chemical, as well as in the manufacturing industries in a variety of ways. For example, being a good solvent, it is used in pharmaceutical preparations like tincture of iodine, cough syrups, and tonics. It is also used in the manufacture of organic compounds like acetaldehyde, acetic acid, and chloroform. In the automobile industry, ethanol is used as antifreeze in radiators. Alcohol consumed in moderate quantities serves to relax the body. Ethanol, therefore, is widely used in the manufacturing of alcoholic beverages like whiskey and beer. Alcoholic beverages are popular because they help people relax. However, consuming alcohol is not recommended, as alcohol consumption affects one's health adversely. Consumption of alcoholic beverages can depress the central nervous system and seriously impair an individual's sense of judgment, timing, and muscular coordination. Ethanol, which is widely used by industries today, is being misused by the general public. To prevent the misuse of ethanol and to make it unfit for drinking, methanol is added. Methanol is poisonous, and unlike ethanol, the consumption of methanol in very small quantities can cause death. Here is what happens when someone consumes methanol. Methanol gets oxidized to methanal in the liver. Methanal reacts rapidly with the components of cells, causing the protoplasm of the cells to coagulate. Methanol also affects the optic nerve, causing blindness. To identify alcohol meant for industrial use, it is often colored blue by adding substances like copper sulfate. Clearly identifiable alcohol that has been made unfit for drinking is called denatured alcohol. The word denatured implies to the removal of its usefulness as a beverage. From alcoholic compounds, let's move to another important group of organic compounds of carbon, carboxylic acids. Carboxylic acids contain a carboxyl group, COOH, as their functional group. A very common item in our kitchens, vinegar, is actually a carboxylic acid. It is also referred to as dilute acetic acid. Vinegar is actually a 5 to 8% solution of acetic acid in water. Acetic acid is a member of the family of carboxylic acids. The molecular formula of acetic acid is CH3COOH. To begin with, let's analyze the formula to derive the IUPAC name for acetic acid. Acetic acid has 2 carbon atoms. Therefore, the root word for the name of this compound is eth. As it is a saturated compound, it is given the suffix -ane. However, due to the presence of the functional group COOH, a secondary suffix, oic acid, is added instead of E. Therefore, the IUPAC name for acetic acid is written as ethanoic acid. In the laboratory, ethanoic acid is prepared by the oxidation of ethanol. Ethanol is treated with acidified potassium permanganate or acidified potassium dichromate to oxidize it to ethanoic acid. Let's analyze some of the physical properties of ethanoic acid. It is a colorless corrosive liquid with a pungent odor. The melting point of pure ethanoic acid is 17 degrees centigrade. Therefore, it often freezes during the winter and is known as glacial acetic acid. It is miscible in all proportions with water, ether, and ethyl alcohol. Compared to mineral acids, it is a weak acid. Therefore, on testing for acidity using a universal indicator, ethanoic acid changes the color of the indicator to orange. Mineral acids like hydrochloric acid, on the other hand, change the color of the universal indicator to red. Let's now analyze the chemical behavior of ethanoic acid. Ethanoic acid reacts with weak bases like sodium carbonate or sodium bicarbonate to give sodium acetate and carbon dioxide. This is an important characteristic property which can be used to distinguish a carboxylic acid like ethanoic acid from an alcohol like ethanol. To demonstrate this property, let's perform an experiment. Take two test tubes and name them A and B. Then, take 2 ml of ethanoic acid in test tube A and 2 ml of ethanol in test tube B. Add a spatula full of sodium carbonate to these test tubes. You can observe effervescence in test tube A, which is due to the evolution of carbon dioxide gas. On the other hand, in test tube B, there is no change. This is because ethanol does not react with sodium bicarbonate. Ethanoic acid reacts with ethanol in the presence of concentrated sulfuric acid to undergo an esterification reaction. Let's perform an experiment. Take a test tube with 1 ml ethanol and 1 ml of glacial acetic acid. Then, add a few drops of sulfuric acid to this solution. Warm this mixture in a water bath for at least 5 minutes. Finally, pour this mixture into a beaker containing 25 ml of water. You will find the resulting mixture will emit a sweet characteristic smell. In this reaction, it produces ethyl acetate, which is an ester. An ester is a carbon compound identified by its sweet fruity smell. Esters are used in the preparation of perfumes and as flavoring agents. Ethanoic acid reacts with bases to give salt and water. For example, it reacts with sodium hydroxide to give sodium acetate and water. Esters react in the presence of an acid or a base to give back the alcohol and carboxylic acid. This reaction is known as saponification. Thus, ethyl acetate, produced in an esterification reaction, gives back ethanol and ethanoic acid in the presence of an alkali like sodium hydroxide. Saponification reaction is used in the preparation of soaps. Soaps are prepared by the hydrolysis of a fatty acid ester with sodium or potassium hydroxide. As mentioned earlier, a 5 to 8% solution of acetic acid in water called vinegar is widely used to preserve food items like pickles, jams and juices. Ethanoic acid is used for making cellulose acetate an important ingredient in the process of making artificial fibers. Artificial fibers are used in the textile industry. Further, ethanoic acid is used for coagulating latex to prepare rubber from it.